Hello everyone. My name is Dr. Poonam Agrawal. I am Associate Professor at Department of Applied Sciences and Humanities at ABES Engineering College, Ghaziabad. So now we have come to the third part of chi-square test. Here in this video lecture, we are going to understand the application of chi-square test as a test of independence. For this application of chi-square test, we will need the understanding of contingency tables. So here we are also going to learn how to construct contingency table. And then we will develop the better understanding of the concept with the help of a few examples. So as I have told you earlier also, this is the notation that we use for chi-square. So as a test of independence, we apply chi-square test to determine whether two characteristics or two attributes of the given data are independent to each other or whether these two attributes are associated to each other in some way. So for this application, we assume as a null hypothesis that both the attributes or both the properties of the data are independent to each other. And we, in alternate hypothesis, we considered that both the properties are associated to each other. So the observed frequency of the data is given to us in the form of a two-way table, and for the purpose of calculation, which gives us observed frequency of the data, and for the purpose of calculation of expected frequency, we make use of contingency table. The degree of freedom in this case is calculated as R minus 1 into C minus 1. As I told you that the data is given, observed frequency data is given to us in a two-way table. So it will have a certain number of rows and a certain number of columns. So if we consider R as the number of rows and C as the number of columns for data distribution, then R minus 1 into C minus 1 will give us degree of freedom. In this condition, remember that while data is given to us, sometimes an extra row or extra column or both are given to us for total. That is not data distribution, so that will not be taken into account. So again, the method and formula for chi-square test is going to remain same. First, we need to declare null hypothesis H0. Then we will declare alternate hypothesis H1. Then most of the time, alpha, that is level of significance, is considered as 0.05 if not mentioned otherwise. Then beta, that is degree of freedom, is, as I told you in the previous slide, is equal to R minus 1 multiplied by C minus 1. Next, we find out chi-square statistics by using the same formula, which is summation OI minus EI whole square upon EI, where OI is going to be observed frequency and EI is going to be expected frequency or theoretical frequency. Again, here's the table that is used for the purpose of finding chi-square tabulated, and chi-square tabulated is found by keeping level of significance alpha and degree of freedom beta in mind. The first row gives us level of significance, first column gives us degree of freedom, and their intersection point gives us the required value, tabulated value of chi-square. So before moving further towards the example, we are going to learn how to construct contingency table. Suppose we are going to understand this with the help of a few examples. Suppose this a two-way table is given to us with the data 2, 10, 6, 6. You can see that this is a 2 by 2 table. Now for the contingency table, first make an extended table which has one extra row and one extra column. That is, the new table will be of order 3 by 3. So since this is the first example, I am going to explain it in detail. Write down the given entries first, and now in the extra rows and columns, write down the corresponding summations. So here you will have 2 plus 10, that is 12. Here again 6 plus 6, that is 12. Here you will have 2 plus 6, that is 8. And here you will have 10 plus 6, that is 16. So this is row sum. This is again row sum. This gives you column sum, column sum. And finally write down grand total in this column. And grand total is sum of all the row sums, or sum of all the column sums, or sum of all the entries. So 12 plus 12 equals to 24 will be the entry. You can write it as 8 plus 16, which is obviously is going to be same as 24, or 2 plus 10 plus 6 plus 6 is 24. So this is what we get in this extended table. Next we get contingency table. So this is the contingency table. Here write down the obtained sum in the external rows or columns, outside rows and columns. Now, to fill these entries, the formula that we use will be row sum into column sum divided by grand total. So here the entry will be 12 row sum into 8, that is column sum, divided by 24. So corresponding row sum into corresponding column sum divided by 24 equals to 4 will be the entry for this cell. Next, for this corresponding row sum is 12, corresponding column sum is 16, divided by grand total is going to remain same always. So this will be 8. Next is corresponding row sum into corresponding column sum divided by 24, that is 4, which by chance is same as previous cells. Okay? Next is 12 into 16 by 24 again, that is 8. Hence the new entries are 4, 8, 4, 8. All right. So the given data was in 4 cells or 2 by 2 table was 2, 10, 6, 6, and the new entries will be 4, 8, 4, 8. Now the given data gives us observed frequency, whereas the new obtained data gives us expected frequencies. So you can write down the observed data for observed frequencies as 2, 10, 6, 6, 2, 10, 6, 6. Whereas the expected frequencies will be 4, 8, 4, 8. Corresponding expected frequencies will be 4, 8, 4, 8. So when you have to construct the table for chi-square test, you can make a column for OI, another column for EI, and then the last column as always for OI minus EI whole square. So you can write down all the entries of OI and EI. You just have to keep their correspondence in mind. So if you are writing it column wise, it will be 2, 6, 10, 6. Then write these entries again column wise so that their correspondence does not get disturbed. 4, 4, 8. Right? And then you can obviously find out OI minus EI whole square or EI. So this is how we make use of contingency table. We make use of contingency table to find out EI, that is expected frequency, which is given as a for the observed frequency, which is given as a two-way table. All right. Now with the use of this contingency table, let us try to solve a few problems. See, the first problem tells us that the following table gives the number of good and bad parts produced by each of 3 shifts in a factory. So a factory is there in which the work is done in 3 shifts, day shift, evening shift and night shift. Shift 1, shift 2, shift 3. Okay? And the products are categorized into 2 categories, good parts and bad parts. Okay? So every part has 2 properties. Either it is about the quality or it is about the shift in which it has been manufactured. And we have to find whether the production of good or bad parts, or in particular bad parts, is independent of the shift in which they have been produced or not. Okay? So we have to see whether these two attributes, good part, bad parts or shift, okay, are related to each other or not. So we are going to apply chi-square test here as a test of independence, for which we have to declare null hypothesis first, and in which in null hypothesis we will say that both the attributes are not related to each other. That means the production of bad parts, the production of bad parts does not depend upon the shift in which they are produced. And H1 we will assume that production of bad parts depends upon the shift. Production of bad parts depends upon the shift. That is, both the attributes are dependent upon each other. Right. Next, alpha, since it is not mentioned otherwise, therefore, as always, we consider it to be 0.05. Beta, that is degree of freedom. Now look carefully. The data is given as 3 rows are there and 2 columns are there. Remember that this is column for total, this is row for total. Okay, so R is equal to 3 and C is equal to 2. And therefore R minus 1 into C minus 1 will be equal to 3 minus 1 into 2 minus 1, that is 2 into 1 equals to 1, 2. Right? And therefore the degree of freedom here will be equal to 2. Right? Now, we have to, this is the data given to us which will serve the purpose of OI, and for finding EI we have to construct contingency table. So I have picked the data from here: 960, 940, 950 in first column, 40, 50, 45 in second column, third row and third column, third row and third column, and fourth row are for total. Right? So already total is given to us in the question. So we just have to find out the entries of the remaining cells. 6 cells are there. So this for this cell, the entry will be corresponding row sum, that is 1000, into corresponding column sum 2850 divided by 2985. Right? And when you solve this, you get it equal to 954.77. 954.77. Similarly, this will be 990 into 2850 divided by 2985, which is equal to 945.226. Next entry will be 995 into 2850 divided by 2985, which is equal to 950. Similarly, this will be 1000 into 135 by 2985 equals to 45.27. 990 into 135 by 2985, that is 44.773, and 995 into 135 by 2985 equals to 45. So this is how we have constructed the contingency table, which gives us the values of EI. Right? Now we summarize all the values. So again, now we have to make the table for the purpose of getting the value of chi-square statistics. So we write down the values of OI. Next we write down the values of EI, and then we will prepare the column for OI minus EI whole square upon EI. So as per the given values, in the first column, the entries were 960, 940, 950. And in the second column, these entries were 40, 50, and 45. The Values of EI as per our calculations were 954.77, 945.226, 950, 45.27, 44.773, and 45. And when we apply the formula of OI minus EI whole square upon EI, these values come out as 0.02864, 0.02889, 0.61349, 0.61022, and 0 again. And upon summarizing them, we get them this value equal to 1.28126. So we have seen that chi-square statistics comes as equal to 1.28126. However, chi-square tabulated, that is chi-square at 0.05, 2 can be seen from the table is equal to 5.991. Since chi-square statistics is less than chi-square tabulated, we conclude that H naught accepted. That is, both the attributes are independent to each other. Or production of bad parts does not depend upon the shift. Right? So this is how we have reached to the conclusion using chi-square test as a test of independence. Let us take another example to test the effectiveness of inoculation against cholera, for which following data was collected. We have to use chi-square test to defend or refute the statement that the inoculation prevents attack from cholera. So again, we declare H naught, in which both the attributes are taken as independent to each other. A person will or will not be attacked by cholera does not depend upon whether he is inoculated or is not inoculated. Yani inoculation does not prevent from cholera. Okay? So we take as null hypothesis that inoculation does not prevent from cholera. Inoculation does not prevent from cholera. Whereas in alternate hypothesis, we will consider that inoculation is helpful in prevention from cholera. Inoculation prevents from again alpha is taken to be 0.05. Next, for finding degree of freedom, we find out number of rows. C, data is divided into 2 rows and into 2 columns. Therefore, degree of freedom will be R minus 1 into C minus 1, that is 1 into 1, that is 1. So here the degree of freedom will be equal to 1. Right? Now we have to find values of EI where values of OI along with total are given to us. Right? Using this data, we are going to find values of EI with the help of contingency table. So how are we going to find the values in the empty cells? Using the same method, that is corresponding row sum into corresponding column sum divided by grand total. Again, the values of total were already given in the problem. So we just have to find out 190 into 170 divided by 790, that is 40.886. Similarly, 600 into 170 by 790 equals to 129.11. Then 190 into 620 divided by 790 equals to 149.11. And finally, 600 into 620 divided by 790 comes out as equal to 470.8. So these values that we just calculated will serve the purpose of EI. OI was already given to us. So we put the values in the table so that we can easily find out chi-square statistics with the help of summation of OI minus EI whole square upon EI. So when taken in order, the values were 30, 140, 160 and 460. And the corresponding values were 40.886, 129.11, 149.11 and 470.89. And when these values are calculated, they come out as 2.9898, 0.918, 0.795 and 0.252, and the summation is obtained as 4.863. Hence we get chi-square statistics as equal to 4.863. Now when we look at the table for finding chi-square tabulated, that is chi-square at 0.05 level of significance and 1 degree of freedom, we find this value is equal to 3.841. Since chi-square statistics is greater than chi-square tabulated, H1 accepted. We conclude that H1 is accepted. That means inoculation prevents from cholera. Prevents from cholera. All right. So this is how we have drawn the conclusions using chi-square test as a test of independence. I hope these video lectures on chi-square test would have proved useful to you. Thank you.